Hey guys, we are going to be taking some notes today. So this is day 7 notes. We're kind of backtracking. We skipped around because of the weird schedule, but if you're wondering where we are in the binder, it is page 28. So page 28 is where we're taking these notes. It's one-page notes, and it's about solving linear equations. All right, so let's quickly talk about the 3 types of solutions I get while solving a linear equation. I could have an identity equation. An identity equation is when the left side is equal to the right side. So here is an example. If I have 3x plus 15, and when I distribute the 3 here on the other side, I also get 3x plus 15. I can pause here. I can stop and say, oh, this is the same thing on the left as it is on the right, the exact same. In this situation, the answer is going to be infinitely many solutions, IMS. If you don't recognize that the left side here is equal to the right side, you could keep going, right? You could try to solve the equation, but what you're going to find happens is that the variables are going to cancel out on the left and on the right. And what you're left with is 15 equals 15, which is a true statement. So if all of the variables drop out and you get a true statement, the answer is going to be infinitely many solutions. Some teachers call this all real numbers, or they do this fancy R, which stands for the set of all real numbers. All of those are acceptable answers. I prefer IMS for infinitely many solutions. The second type of equation that we can solve when it's linear is something called a conditional equation. This is what we're mostly used to. You get a single answer. So if I divide both sides by 3, in this second example, I get x equals 7. This is called conditional because what it means is if x equals 7, then the statement is true. Then the equation holds. So a conditional statement is one of those if-then statements. So if x equals 7, then the equation is true. And when you have a conditional equation or a normal equation, you get one answer. You get a single numerical answer. And finally, there's a contradiction equation. When we have a contradiction equation, we get a special situation where the variables also are going to all cancel out. But instead of being left with a true statement, a contradiction is when you're left with a false statement. So 0 obviously does not equal negative 21. My variables all canceled out and I got a false statement. So there is no solution that can make the left side equal to the right side. So this is a no solution. Now there's other ways to write no solution. You could do a circle with a line through it, or my personal favorite, it's a no-so. Okay, but those are all ways to say no solution. So those are the 3 types of equations. Now, I have some problems for us to try. These are just solving linear equations. So just kind of a reminder of solving equations and the rules. So number 1, we can combine like terms and get 2x minus 4 equals 2x, 12 minus 16 is negative 4. And I'm going to stop right there because my left side is exactly equal to my right side. So this is IMS, infinitely many solutions. It's an identity equation. Okay, on the left side, I don't know why I said on the left side, number 2, on the left side of this, I'm going to move over the x's, right? So I'm moving over the x to the left side. I'm left with x minus 10 equals 25. Add the 10 over. And I'm not going to show every step. You guys have seen these problems before. So add 10 over to the other side. 25 plus 10 is 35. Ooh, kind of a weird shape, but we'll go with it. All right, this is obviously a conditional equation where I got one answer. Totally fine, totally normal. All right, let's move on to number 3, solving a linear equation, combine like terms. These are on the same side, so it combines to negative 3x plus 5 equals 5. Okay, I'm going to subtract this 5 over to the right. And when that happens, they cancel out on both sides. This does not mean it is a no solution. Negative 3x equals 0. Well, if I divide over the -3, 0 divided by -3 works. It's 0, and 0 is a number. It counts as an answer. X equals 0 is the answer here. All right, so that's actually a conditional equation. I got a singular answer. I bet we can guess what's going to happen in this one. I have a 7x minus 4 equals 18 minus 11 is 7x. The 7x's will cancel on both sides. I'm left with a false statement. Obviously, -4 does not equal 0, so this is a no-so. No solution. Let's just step up our game a little bit and solve some harder equations that involve fractions, that involve decimals, and so on. Starting with number 5. So I distributed the 6. Now, distribute the negative. It goes to both the 10x and the 14. Okay, so I have an 18x minus 6. I'm going to rearrange this a little bit and combine like terms. So negative 10x plus 22. I am going to add the 10x to the left, and I'm going to add the 6 to the right. So I get 28x equals 28. Divide over the 28 to get x equals 1. So this one was a little bit more difficult because if you forget to distribute the negative, your answer will be incorrect. All right, number 6. Guys, you can clear fractions out to make your life a lot easier with equations. So this is how you clear fractions. Look at the denominators. The common denominator of those would be 6. So if you multiply everything by 6, and when I say everything, I mean every part, that'll wipe out the fractions. So I have to distribute. 5 over 6 times 6, the 6's cancel, and I just get 5x. But I do have to distribute, right? So the 6 goes to the 2 as well. I get a minus 12x. 6 times a third. 6 over 3 is 2. So this is plus 2 equals, and here again, I can use my calculator if I want to multiply 2/3 times 6. The trick I like to use is take 6, divide it by the bottom, and then multiply that by the top. So 6 divided by 3 is 2, times 2 is 4. All right, and now I've cleared the fractions out. So now it becomes a lot easier to solve. All right, so combining like terms, I get a negative 7x equals, I'm going to subtract over the 2, so equals 2, and divide over the negative 7. It's okay to get a fraction answer. It doesn't mean you did it wrong. Okay, there's also a trick with decimals, okay? So what I personally would do is multiply the left side and the right side by 10. Okay, now the reason I'm multiplying by 10 is because if I multiply by 10 on both sides, it takes the decimals and it moves all of them over one spot. That's what you do when you multiply by 10. You add a tens place, essentially. So this is kind of weird because you don't want to over distribute. On the left, you only distribute to the numbers outside of the parentheses. Otherwise, you're going to over distribute. So this actually becomes a 3 parentheses x plus 2 minus a 5 parentheses x plus 2. All I do is move the decimal over one spot equals negative 2 minus 4. Excuse me. And now all the decimals are gone. It becomes a lot easier to solve. So I'm going to distribute the 3x plus 6, distribute the negative with the 5. So minus 5x minus 10 equals, combine like terms, negative 6. So 3 minus 5 is negative 2x minus 4 equals negative 6. I'm going to add over the 4, so negative 2x. So I'm going to add over 4 equals negative 2, divide over negative 2, so x equals 1. Again, I went through solving that quickly, but that's because with linear equations, I do expect us to know how to do these steps, okay? Now the last one, definitely challenging again. Again, I would clear the fractions out. I'm going to change this to a plus negative. And again, I would clear the fractions, so I got to figure out what number does all the numbers 2, 3, and 4 all go into. That number's 12. Ooh. So I'm going to multiply my left side by 12, but I also have to multiply my right side. All right, so when I multiply the 12 here, 12 over 2 is going to reduce to 6. It looks like this, 6, and then I'm left with that x plus 1. That's when I multiply the first fraction. When I multiply the second fraction, 12 over 3 is 4. I still have the x minus 8. And 12 over 4 is 3. So that's times the negative 2x. And that on the other side, 12 times 4 is 48. And now I trust that you can finish solving this, so I'll do it quickly. I get a 6x plus 6 plus 4x minus 32 minus 6x Okay, let's combine like terms. Ooh, 6x minus 6x cancels. I'm left with 4x minus 26. When I add 6 and negative 32, I get negative 26 equals 48. I'm going to add over 26. So I get 4x equals 74. So x equals 74 over 4. I would reduce that fraction. All right, so that's going to be 37 over 2. And again, it's okay to get a fraction answer. That's okay to get a fraction answer. Okay, so that is the moral of the story. That's what's going on with linear equations. So your job is now to do worksheet 7. Okay, it's just 10 problems. Try it out, see how you do, and use these notes to help. Thanks, guys.